Hello, I'm Professor Peter Openshaw. I'm at Imperial College London. I'm Professor of Experimental Medicine. I'm a lung specialist, but I'm also an immunologist. I've just finished 5 years as the President of the British Society for Immunology, and I work on respiratory viral infections. I've called this talk The Challenge of Respiratory Viral Infections. It's a challenge both in terms of the global impact of respiratory viruses, but also I'm going to tell you about some challenge studies where we've been infecting volunteers with 2 of the common viruses. So to first put it in context, if we look at the global impact of lung infection, you can see that lung infections themselves have a huge impact on health. Measured in disability-adjusted life years lost, you can see that right at the top of the scale, we've got lung infections. This is mainly pneumonias and in childhood, mainly in low and middle income countries in, say, India, in Southeast Asia. But we've also got tuberculosis, another lung infection, I've put here COPD, chronic obstructive pulmonary disease, and asthma because these 2 diseases are frequently exacerbated by viral infections of the lung. And without them, these other diseases would have much less impact. So my 2 favorite viruses, influenza and RSV. Just to compare the 2 very briefly, influenza gets around the problem of reinfection by constant mutation. So every year it changes into a different virus. It becomes antigenically distinct from its predecessors. So constant mutation allows it to run away from the immune response that's been generated by its ancestors. Whereas with RSV, it adopts another strategy, which is to interfere with the host immune response. So the immunity that's generated by infection with RSV is transient and inefficient. It's perfectly possible to reinfect somebody by inoculation with exactly the same strain of RSV repeatedly. And we've done this experimentally. So 2 different approaches, same result, the virus can continue to circulate. We normally think of RSV as a virus that mainly affects babies. So here we've got RSV bronchiolitis. So the typical story would be of a baby catching a cold, which then goes to their chest, makes them very wheezy, maybe causes hospital admission, rarely causes the need for mechanical ventilation. But these babies who've been into hospital with bronchiolitis often end up having recurrent chest troubles during later childhood, maybe up to 11 years of age. They develop this recurrent post-bronchiolitic wheeze in response to a variety of stimuli. It's not quite clear whether the RSV actually causes permanent damage to the lung, but it's plausible that that is the mechanism that causes that association. Then we've got exacerbations of lung disease in adult life, exacerbations of COPD and asthma. And then in older adults, we've got this curious, fairly newly described syndrome of insidious respiratory disease, which is caused by RSV infection. The typical story might be of catching RSV over Christmas when the grandchildren come home. By maybe the 2nd week of January, the virus has gone to the chest of Granny, who's maybe a little debilitated and smoking quietly in the corner. And maybe by the 3rd week in January, she may have died because of the complications of RSV disease. So it can be it can get under the radar and be quite hard to detect because by the time it's picked up, the virus has actually gone and left those complications. So we're in a very exciting time now in terms of RSV vaccine development. There are many, many vaccines in the pipeline. RSV is one of the last big challenges to the vaccine developers in terms of common disease for which we think there's every reason to believe that it's possible to make a good vaccine. And there are many different approaches being developed, from the live attenuated vaccines, which are developed in a number of different ways, but there's some really interesting ones which may get around this problem of immune suppression. Monoclonal antibodies, which can work like a vaccine but confer passive immunity which could last through a whole season. That looks very promising too. Then we've got the vector-based vaccines, where There's genetic engineering approaches are used to put in bits of the virus and stimulate a very strong response. More classic subunit vaccines, and then mucosal vaccines, which can be administered via the mucosal tract and cause protection where it's most needed. So in order to try to accelerate these vaccine developments, we've instituted a network called HICVAC, which is there to try and support people in the use of human infection challenge of volunteers. This may seem an odd thing to be doing, to actually specifically aim to induce disease in order to find a vaccine, but it does really speed up the whole process of vaccine development, as well as contributing to understanding. So we've got £3 million from the Medical Research Council in the UK to hand out to members of our vaccine consortium network. We've got well over 200 members now, both in the UK and elsewhere. And our aim through the network is to really support and promote the use of human infection challenge. And we've been doing this ourselves with RSV and with influenza. So at the moment, we've got 124 members in the UK, 107 outside the UK, many of those people in low and middle income countries, which of course are most impacted by these infections. And if any of you are interested in becoming members, please get in touch through our website, and we'll see if we can support any of the studies that you would like to do using Human Infection Challenge. So I won't tell you in many details about the results of these challenges, but just in brief, when we infect volunteers with influenza, there's a very rapid onset of symptoms in those who become infected. It peaks on about day 4. And then by day 10, virtually everyone has become completely asymptomatic. With RSV, there's this interesting lag period after inoculation of the virus, during which nothing seems to be happening. And then in those who become infected, we have this increase in symptoms, which develops slightly after that. Just to point out one other thing, with influenza, we have to make sure that the volunteers are seronegative. Whereas with RSV, we take people regardless of the presence or absence of antibody, because that only makes a small contribution to the frequency of infection. I showed you what happened with symptoms. Same sort of thing happens with viral load. So again, after infection, the viral load accumulates quite fast in those who become infected. But with RSV, there's this lag period again, which is really interesting. And we're trying to work out what it is that's going on during that period of negotiation between the virus and the host. The virus may be instructing the host immune response to dampen down, and the host immune response trying to mount some sort of response in order to defeat the virus. So to sum up, we've got these two really interesting viruses, influenza and RSV. With influenza, many symptoms are developing quite quickly. The peak of inflammation is relatively early, and the immune responses which are most protective are evident in the lung rather than in the blood, and the B-cell responses, the antibody, is quite prolonged. With RSV, on the other hand, we have this lag period. There's inflammation which really continues after the peak of symptoms. This is a completely new observation. We don't know how to explain it. But again, we've discovered that we have to study the local inflammation in the lung and in the nose in order to understand what's going on with the virus. So there's been a very quick window into the sort of research we're doing. I hope you find this interesting, and thank you very much for watching.